So here is a question. Here are the first 5 terms of the quadratic sequence: 5, 11, 19, 29, and 41. Find an expression in terms of n for the nth term of the sequence. So let's start off by writing down the terms: 5, 11, 19, 29, and 41. This is our sequence. As usual, I'm going to find the difference between each of the terms. So this is the difference of 6, 8, 10, and 12. Okay, so this is the nth term, terms actually, this is the difference between each one. As you can see, there's a constant increase between each of the differences. So the differences are not constant, but what's constant is the difference between each of the differences, i.e. this is 2 plus 2 plus 2 and plus 2. Okay, and that is very important. That lets us know, firstly, that we're dealing with a quadratic sequence, and secondly, what the n squared is going to be. What is the coefficient in front of the n squared would be. So as this is plus 2, whatever the difference is between the differences, you divide that by 2. So in this case, we're going to be doing 2 divided by 2, because 2 is the difference between each of the differences, and divided by 2 because that's the rule of the coefficient in front of the n squared. So here we'll just leave 2 over 2, which is 1, and we'll leave that as it is. And then we do the top line subtracted from the bottom line. So firstly, what is the bottom line? We have to put in, for the first term we put down 1, second term we put down, when n is 2, it's going to be 4, because 2 squared is 4. When n is 3, it's going to be 3 squared, which is 9. 4 squared, which is 16. And 5 squared is 25. Okay, so 1, because this is the first term, this is the first term as well, and this is we're putting in 1 because it's the first term. For the second term, we put in 2. For the third term, we're putting in 3 into the n squared, and for the fourth term, 4, 5, and 5. So when you do this minus this, so let's just write that down. 4, 7, 10, 13, and then 16. This is a standard arithmetic sequence. It's the one that we've been doing before, because we've removed the n squared aspect of it. We've removed the n squared part of the equation. So now you can see that the change between each one, it will be constant. So this is plus 3, plus 3, plus 3, and then plus 3, because 16 minus 13 is 3, 13 minus 10 is 3, etc. Okay, and then what do we do after that? You should be able to calculate this yourself because of previous examples, but for those who don't know and this is the first time they're watching this video, what we're going to do is we're going to have 3n, because the difference between each term is 3, and then plus 1, because if we assume that we were looking at the first term, the first term, if we put 1 into the equation, it will give us 3, but the first term is actually 4, so we have to put 1. Okay, and then if you check it with, let's say, the fourth term, which is 13, 3 times 4 is 12, plus 1 is 13, so we know we're correct in this aspect. And then what do we do? Is this the final answer? No, because there's an n squared that we took out, so we have to put that n squared back into the final equation, and this is your final answer. Remember, always check our answers. So how can I check this? We've checked that the 3n plus 1 is correct. How do we check the whole thing is correct? By simply just putting in a random number, let's just say 5. Put 5 into this equation. 25 plus 15 plus 1. That's going to give us what? 41. Is that correct? Yes. You can double check and put in another number. Let's say 2, for example. 2 squared plus 2 is 3 multiplied by 2 plus 1. And this will give us 11. I hope that makes sense.